This looks like it's all working. Hello? Okay, I can see stuff on my mic is working. People at home, in a little while, and maybe you want to try multitasking. Actually, don't multitask. But in a little while, you're going to need to look for a version of this. Actually, you know what? I could probably just keep this on my screen. And if you want a copy of this when you get back, I can give it to you. But we're going to be learning how to do relative dating today. And that's what the warm-up is about. So this is, I don't know what the date of this thing is, but sometime back in around 1997 or so, I would guess from the look of it, I drew this out. This was back when I used an overhead projector when I taught 8th grade. Every day I would have a little transparency that I would write what we're doing and a warm up, and I'd put it on the projector. And it was kind of like this, except it was on the overhead. So this is an old warm up, and this was the way I introduced relative dating. So suppose I have this pile of, oh, and by the way, relative dating just means putting things in order. So if I relative dated this table, I would say the table was here first, and after that came these little metal gas spouts, and the next oldest thing on this table is, I don't know, this paint that's right on here, and then I'd get to newer things that this just arrived this morning. I just put this on the table. So that's kind of how relative dating goes. I'm not going to say exactly how old anything is. We're just putting things in order. So if you have a pile of papers like I do here, which papers have probably been there the longest? The ones on the bottom or the ones on the top? This is supposed to be an obvious one. Got a pile of papers. Which ones have been there the longest? The ones on the top or the bottom?
Bottom.
Bottom, yes. Okay, so there's actually a name for that kind of reasoning. That's called the law of superposition. And that says if you have different layers of the earth, if you go out and you dig a hole and you dig down deeper and deeper and deeper, you might dig through the grass, and then you hit some big roots after that, and then you hit some other stuff. As you go lower, the stuff is older. That's what the law of superposition says. So we're going to be using the law of superposition to figure out things like, in this diagram, which one of these layers is the oldest, which one's the youngest, and all that stuff. All right, so now there's this other question. 2 and 3 are really similar. They use the same principle. So number 2 says, Mr. Stapleton spilled battery acid on his stack of papers. Which layer of papers is barely newer than the battery acid incident? So I've got papers A, B, C, D, E, F, and G. 1, 2, 3, 4, 7 papers were on my desk. At some point, I spilled some battery acid on these papers. And so which paper came right after the battery acid spill? Just blurt it out if you know it. I'll zoom in. Which one of these? So can you see what the battery acid did, first of all? You see the damage that it did? The damage is right here. It burned this hole. So which paper was laid down right after the spill? C, yes. So this is called the law of cross-cutting relationships. And there are a lot of different ways to state this, but here's one way you can do it. Pretend you didn't see me do that. I didn't do that. So you just come along and you find this paper that's got this little slit in it. What would you assume? The paper was there, the paper existed first, or the cut existed first? The paper. So the law of cross-cutting relationship says if something gets cut by something else, the thing that gets cut had to be there first. So you can't be cut by something if you're not there first. Just like, if I stick my finger out and I cut it off, my finger has to go there first before I can cut it. I can't cut it before my finger's there. I know that's so obvious, it's almost confusing. So With these papers, though, the ones that were cut by the battery acid, they had to be there before the battery acid. The ones that are not cut by the battery acid came after. And if you combine that with the law of superposition, if you look at C and B and A, all those came after, but which of those is probably the oldest, A, B, or C? Here's A, here's B, here's C in this stack of papers. A is probably the oldest. I'd say C because it's on the bottom. Now, I guess this is assuming that I'm forming a stack like this. I set down a piece of paper on my desk, and then I set another piece of paper, and then I'm cleaning up a little bit, and I add something else to that, and then I add something else to that. So the oldest thing, the first thing's on the bottom, the other things come up here. But what happened in this case was I put some papers on my desk. I was, I don't know, drinking battery acid, and I spilled it on these. It made a hole through. Then I put some other stuff on top. And all this new stuff on top came after the acid spill. And if you uncover it until you see the first one that's been cut with that hole, that'd be like layer D here. So the law of superposition says the oldest thing's on the bottom. So G would be the oldest, then F, then E, then D, then comes the battery acid spill that cuts through all those. It's got to be newer than all those. But then C comes along and is on top of that, so it's got to be younger. This is kind of confusing. It'll get less fuzzy. So those are really the only two rules we're going to be using much. The law of superposition, which says lower things are older, and the law of cross-cutting relationships that says if something gets cut, it's older than the thing that does the cutting. And the thing that does the cutting is younger than the thing that it cuts. So here we go. The number 3, the picture on the right shows 2 needles piercing a stack of papers. So again, in this stack of papers, one could assume that the oldest paper is on the bottom and they're laid down like this, and the newest one's on the top. But a saw came along and cut through the stack of papers and also cut through these needles. Now the needles have been poked through the papers. I don't know why somebody would want to stab a bunch of needles through papers, but the needles were stabbed through the papers, maybe just to keep them in place, keep them from blowing away. And then the saw comes along and does the cutting. So the question is, which needle pierced the stack last? So which needle came last? Needle A or needle B? Needle A. And you can tell it's needle A because this saw went across here and it didn't cut needle A. It cut needle B, but not needle A. So the law of cross-cutting relationships says if something gets cut, it was there before the thing that did the cutting. If something's not cut, like A, then it must have come after the cutting occurred. So everything got cut except for A. So the papers got cut, the needle B got cut, all those things were there before the cutting happened. Then the saw came along and cut the whole stack in half, and then needle A must have gone through because it didn't get cut and broken like everything else. It had to come last. So that's what you need to know for this. People in here already have this sheet. People at home, if you want to run and print this out really quickly so you have your own, I'll show you where to do it. But if you don't want to, you can just follow along and maybe get a scrap sheet of paper to work on. Actually, definitely get a scrap sheet of paper to work on. But the sheet of paper that I'm going to be working from, you can find in Google Classroom, and hopefully under classwork. Rock dating is the new thing. The Google Meet, I think I put it in there. So if you open that up, there's a link right here. And this is the paper I'm going to be working from. So I guess I could just show it in this window just like this, but I think I'm going to use my camera instead and use the physical one that's on my desk. don't know what this is. Oh, that's me. There I am again. So looking at this, up at the top, this is just some background information. Sorry, I've got to find my pencil. And some of it I've shared with you. Some of it is not actually stuff you're going to have to know, because this year we're just doing relative dating. We're not doing what's called absolute dating, or at least I don't think we are. And by the way, this doesn't mean you're dating your uncle or your sister or your cousin. It just means instead of figuring out the exact real numerical age of something, we're just putting things in order. So we're saying this is the oldest relative to this. This first thing, this principle of original horizontality, that's not really very important from what we're doing. What this principle says is that if these are layers of rock, or if these are layers of rock in here, originally all the layers get laid down horizontally. So if you look at layer K right there, that was probably just laid down. This could have been some sediment that was at the bottom of the ocean, or maybe some sand that was in a desert that it just all blew out in an even layer, or maybe this is ash that settled out from after a volcano. But original horizontality says it's horizontal in the beginning. And later on, if you find something that's like this, that means something happened to that. That got squished, and this would be like, oh, forgot I didn't go over the homework. We'll do that after this. I was going to say like metamorphic rock, it gets squished. And if something gets tilted, I don't know if I have any examples of tilted stuff in here. This is tilted a little bit. So that just, original horizontality says it wasn't like that in the beginning. All layers are laid down horizontal, even with the Earth's surface. But we're not actually going to be using that. I don't even really know why I put that in there, except it's one of the principles of relative dating. Relative dating, this just explains what it is: comparing or ranking the ages of rocks without actually determining their ages. For example, with relative dating, we might say a rock A is older than rock B, but we don't know the actual age of either rock. That's what we're doing. Absolute dating, that's where we would be determining the exact age, and we'd use radioactive atoms to do that, and there'd be a lot of math and graphing, but I don't think we're going to do it this year. Principle of superposition. This is an important one. This is the one that I was saying. This is a different way of saying it. The closer a rock layer is to the surface, the younger it is. So super means sort of better or above. Position is where it is. Superposition, this principle is called that because things that are above are younger than things that are below. So as you go down, you get older. As you go up, you get younger. Principle of cross-cutting relationships. This is an important one. If a layer of rock is found cutting through another rock layer, the layer which is cutting must be the younger one. And it doesn't have to be a rock that's cutting through one. It could be something else. And then this may be important later. This is the principle of faunal succession. You may have heard of flora and fauna. Has anybody ever heard of flora and fauna? What does that mean? It means plants and animals, or animals and plants. So faunal succession has to do with animals and plants that get buried over time and leave what around? The impressions of plants and animals. It begins with an F. Yeah, fossils. So there's the fossil record that helps us put these in order too. We're not going to be using that right now, but these two we're going to use over and over again. So here we go. Let's put all these in order. The youngest we're going to list here. The oldest we're going to list there. You might be able to already do this, but I might need to clarify some things. So I'm going to be asking myself these three questions. This is just the way I do it. You can do this however you want, but this is my way. So I start at the bottom, and I start, because the oldest thing should be at the bottom, and then I start working my way up, and I ask myself which layer reaches highest. So if I'm at the bottom, I've got layer A. That's really the lowest thing. Forget about this question for a second. Does anybody see anything below layer A? What's that? Yeah, so this is kind of tricky. E if you look at E and D, these are tubes of magma. This would be, I don't know, this could be at a hot spot, it could be at a convergent boundary, but these are tubes of magma that probably extend down this way. So if you were looking at A and looking at those probably go down lower than A. But which layer cuts through the other layer? Does layer A cut through E, or does E cut through A? Look at this. So the way D would form is magma would go blub 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 and burn its way through here, and then E formed like this. But E got broken. So which one cuts through the other? Does A, which is all this stuff, does that cut through layers D and E, or do D and E cut through A? D and E cut through A. So if they cut through it, are they younger or older? They're younger. It had to be there first. So the youngest one is A. So again, start at the bottom unless you want to start at the top, which you can do. You can do this in the other order. Oh, I wrote oldest and youngest right here. That's very confusing, isn't it? Let's put youngest on the right. I think there was some sort of a formatting issue in Microsoft Word when I printed this out. So oldest on the left, youngest on the right. So working my way up, what's going to be the next oldest as I go up from A? Which one is like the next lowest thing in this picture? B? So there's B. Yeah, B would be the next thing. And still, if I look at E and I look at D, they're still cutting through B. So these two, since they cut through B, they're younger than B. So B is the next one. And now as I go up, this is where it gets a little tricky. I get to layer C, and then there's also, if I look at the top of C, this is a good place to look. The top of C is even with the top of E, and that's even with the top of D. Oh, I remember why I said this. Which one reaches the highest? So if I'm looking at A and comparing that to E and comparing that to D, E reaches all the way up to here. D reaches all the way up to there. A only gets to here. So therefore, these two, we could have just used that. These two are younger than this because this doesn't reach as high as those do. But now when I get to C, I've got C, E, and D. Of those three, which one had to be there first? C, why? The other ones cut through it. E and D both cut through C, so C is next. So C is younger than B because it's above it. B is younger than A because it's above it. And all three of them are older than E and D because E and D cut through them. But now, yeah, if I go up to F, then I've gone beyond these two. F is above E and D. So both E and D are older than F. So F's not the next one. Of these two, D and E, which one's older? Tommy says E. Do people agree? Somebody at home, do you agree that E is older than D? If nobody confirms, I'll pick somebody, and you have to either say yes or no. Oh, I'm just going to pick. Laura, what do you think? Is E really older than D? Laura? Are you there, Laura?
Yeah.
What do you think? Is E older than D?
Yes.
Yes? Why do you think so? It's okay if you just guessed, if you don't know.
I don't know, I just guessed.
That's fine. You're right. You guess because Tommy's usually right. Okay, Tommy, what do you think? Why is E older than D? Right. So there's this big crack here. and everything on this side of the crack shifted like this. This is sort of a transform fault. Everything on this side of the crack shifted that way, and everything over on this side of the crack shifted this way. So it all went like this. So there was some kind of probably an earthquake that caused this fault. And when that happened, that did some cutting. It cut through all this stuff. It cut through layer C, it cut through layer B, it cut through layer A, and it cut through layer E. So this earthquake or this fault has to be newer than all those things. But D actually cuts through the quake, so it came later. So there are a couple ways to look at it. The earthquake cut through E, so it's younger than E, but it didn't cut through D, so it's older than D. And you could also say that D cut through the earthquake, so it's younger than the quake. So anyway, the next oldest one would be E. And then in my diagram, in my list up here, I'm going to make a little, I'm not sure if this will end up being important later on, but this is when the quake occurred, right after layer E came along. And then D came along after the quake, and then F. So at some point, the top of E and the top of D, they got worn away, maybe by erosion, by a glacier, by something that just scraped them off. And then F came and settled in. And we know that because of the principle of superposition. It's on top of these other two. All right, so that's your introduction. Now, some practice. I want to give you, I'll give you just a few minutes to try working on this. Some of you are probably going to be really fast, and you're going to get it done quickly. And if you do, just turn on your camera, and everybody else, don't look at your screen, because I want those people to show them, like put your answers right in front of your screen and get my attention, and I'll check them for you and tell you if you're right. I'm going to leave this right here right now, so anybody just looking at my screen can look at it. Anybody who doesn't have the paper, which is lots of you, just list oldest to newest, all these different layers. And as soon as you get it done and you want me to check you, I'll check you. I don't expect you to get it right this time. This is pretty new. You can do the last one if you want. Anybody at home have it done? I can get really close to my screen and see if you got the right answers. pretty soon I want to go over the answers and show you how to do it. But if there's anybody who is pretty close and you want to finish it up before I do it, let me know. Is there anybody who wants me to hold off for a little while so you can finish? I can't tell if you're all working or if you're what you're doing there. All right, you better speak up if you don't want me to give away answers. I'm about to do it. Anna, you look like you're going to say something maybe.
I was just gonna say I'm fine with going over the answers right now.
All right, let's do it. So I start from the bottom. I try to find the lowest layer that I can find. And it's a little bit tricky because over to the right of this fault, I can see J, but if I look over to the left, I can't see J. So is that okay? Where's J on the left side? It's not there. It's there, but it's not there. So where would if I were digging around over here and looking for this layer J, where would I go to dig and find it? Well, over here it's right below C. So the reason I can't see it over here is because everything shifted this way. There was this big shift like this, and the left side shifted down. So J is just somewhere over here out of the picture. But that doesn't really matter. The lowest thing I could see, the thing that's below everything else, is J. So that's definitely the oldest one by the law of superposition. Oop, let me bring my little friend back. And then as I go above J, the next thing that's right there is C. So I'm going to look at C here. I'm going to look at C there. There's also G. G and C are sort of even with one another. The top of G goes to right here. The top of C goes to right there. So I can't really say C is above G or G is above C. So how do I figure out which one's older? Definitely C or G is next. Which one's older, C or G? I have to use the law of cross-cutting relationships now. Which one gets cut by the other one? Does C get cut by G or does G get cut by C? Hey, which one's cutting through? All right, I'm going to choose somebody. Yeah, Mr. Hill. Actually, Mr. Hill, you can answer this for us. Oh, he's not. So nobody will answer my question.
All right, what's the question?
My question is right here. You can see it right here.
Yeah.
We've got this rock layer C.
Sure.
And then G. G is this magma tube.
Yeah.
I is a magma tube. These are. So the question is this layer C cutting through G, or is G cutting through C?
G's cutting through C.
G's cutting through C. Excellent.
Obviously.
So if G is cutting through C, then C had to be there first. So C's next, and then G. All right. So people at home, Mr. Hill just shamed you. He had no. Well, you can see their names, but you can't see their pictures.
Get it right. Come on. Bye, guys.
Bye. Thank you for stopping in. So after C, moving up, the next thing we've got H and we've got I. So what I'm doing, I start lowest, I work up, and I try to find the next lowest thing. So it's not really H and it's not really I. They're sort of tied. They're definitely below D. So which one's older, H or I? H, because I cut through it. So H had to be there first for I to cut through. So H is next, and then I. And then, so here's H and here's H. So the next thing is D. And there's really nothing else that's even with D, so it's just going to be D next. By the way, these fossils, we'll talk about them sometime. They don't really come into play with what we're doing today. So D is next, but then we've got B, and we've got E, and we've got A, and none of those is really higher up than the other. So Which one's oldest? B, E, or A? B. Yes. And why, Anna?
Because all the other ones are cutting through it.
Right. So B had to be there first for E to come burn its way through and A to burn its way through. All right. Now we've got F is the youngest one. E and A. Of those two, which one's older? E. And this is the same reasoning that Tommy used earlier. If you look at E, it's broken. It's cut by the earthquake. So that means it came before the earthquake. But A is not broken, so it came after the earthquake. It cuts through the earthquake. The earthquake cuts through E. So E was there before the earthquake. Then I'm going to make a little mark here. This is when the earthquake came. And then A came along after that. And then the tops of all this stuff got scraped off, and then F settled on top. All right. So one more practice for you to try. See if you can do this. And hopefully more of you, I'm hoping for maybe half of you to be able to get this all right on your own. After this, I may have a few other things to say to you, but there's a Google quiz over this. Oh, wait. Everybody stop for just a second. Because some of you may just decide, I'm going to leave and go do the Google quiz. Here's the way the quiz is going to work. I'm going to give you, or I've already given you, a diagram that looks kind of like this. And then I'll ask you a question like, which layer or which letter is barely older than B? And the best way to do this is to list everything from oldest to youngest. And then you just, once you do that, you look up at your diagram. There's where B is. So which one's barely older than B? D. Which one's barely younger than E? Or B? I gave the answer away. E. So that's how it's going to work. So when you do the Google quiz, list everything from oldest to youngest, and then answer the questions. That way you don't have to go back and look at the diagram. And if it says, which layer is barely older than H and younger than H, you can just look at H. This one's barely older. This one's barely younger. That's what I mean by the barely part. All right, so work on that. And if you do this and I check it off and I say it's all good and you want to just sign off and go do the Google quiz, you could do that. I'm going to walk around. It looks like somebody's ready in here. I'll be back. Yep, you got it. You want to get your notebook out and do the Google quiz, you can do that. Do you have a thing? After H, if you go up, what's the next layer? Right on that. So you have C. So the thing about I and C, you look at C, it cuts through I. So if it cuts through something, what was there first? Does it cut it or does it got cut? Right. So I would be older than C. If we do a few of those. If any of you are ready to have me check it, just turn your camera on and hold your answers really close up there, and I'll see if I can read them. I might not even be able to read them. Let's see. E is out of place, and you're missing B, Elijah. And I don't know if I saw C. There should be 1, 2, 3, 4, 5, 6, 7, 8, 9. There should be 11 letters in there. Make sure you've got all 11. It's easier if you've got this because there's a blank for each of them. Anybody else ready for a check? Oh, okay. Anna, move it down a little bit. And move it to your right a little bit. So everything's good except for your E. If you just move that E, it's the E's in the wrong spot. Sully, you got it done? I'm gonna go check Sully's. I'll be back. You didn't get it right? So your G and your B are out of place. But everything that they're actually in the right order. G is always B. But they just need to be moved somewhere else. If you took them both and you moved them, then it'd be right. Is anybody else from home finished up? Since I can't see if you're all furiously writing and thinking, do you want a little more time before I show you the answers?
I'm ready.
Thank you, Anna. Hold on for a minute. I'll check. All right, so I'm going to start from the very lowest thing, and the lowest thing I can find in here is this fish scale looking pattern. So it's right there. There's no letter here, but it's the layer below H, and I can see over on the right that the layer below H is F. So F is the lowest thing. That's the oldest. And then after F, I've got H. I'm going to follow H over here, and then there's D. So H and D are kind of about the same age, but D cuts through H, so H had to be there first. So H was there, then D came burning along, melting its way through here. Then apparently the top of D got scraped off by something. And then there was this next layer, I, goes all the way across here that was laid down. But there's also C. But I know that this had to, it's not like there would have been just this column of magma sticking up into the air like a funny tree, and then I formed around it. So C cuts through I. I had to be there first. So I is next, then C. And then the next thing above those, we've got J. J goes all the way across there. There's really nothing that's, if I look at the top of J, there's nothing that's really even with that. There are these two things, E and A, that go through it. What's my deal with E and A? I don't know why I used E and A over and over again for these magma tubes. I hope I didn't do that on the Google quiz. So J is the next one. And then above J, there's layer G. And G is still older than A and E because they cut through it. And then above G is this one, layer B. It's right here too. And right here, this is all B. So there's B and A and E, but you can see E cuts through B and A cuts through B. So B had to be the older one. And then E and A, you have to use the earthquake. E is broken by the earthquake, and A isn't. So I don't know why all these, there's an E and an A and an earthquake between them. At least it was E and D on the front and not E and A. But these last two, I think that's just kind of coincidence. But then the very last one, the one that's above all those, is K. So if this were your quiz, there would be things like which layer is barely older than A and which layer is barely newer than A. and the barely older one is E, and the very newer one is K. And if you don't have all the letters listed out, then that could mess things up. Like if you forgot to list B, and I asked you which one's barely older than E, you would tell me it was G. So make sure you've got all 10 letters listed on that Google quiz. I'm going to go back to my website and make sure that I've told you everything I need to tell you before people sign off. So, the homework. We never reviewed the homework. So I want to go over the homework really quickly. And I want to get this out of that window over there. You don't know what I'm talking about, but it's bothering me. Introduction to relative dating, we did that. Rock dating, this is the handout, so everything there is in Google Classroom. Practice, everybody do the quiz in Google Classroom. And then study. So we're going to have a quiz over the rock cycle, igneous, metamorphic, and sedimentary. For these blue people, it's going to be on Monday. And for the gold people, it's going to be Thursday. So first thing I want to do is, or this is the last thing I want to do, go to Google Classroom and open up last night's homework and go over that quiz really quickly. Here. 10 people did it. Now, this says 8 assigned. That doesn't really mean 8 of you didn't do it. There are a couple of teachers in there, and then there's this thing called a test student, but I think about 6 of you didn't do it. So here are the answers. I suppose you've already done this, but I'm going to do it anyway. Wanted to put my picture there. What type of rocks form when another rock's broken into bits and compressed? That's sedimentary rock. That's like breaking something into sediment. What type of rock is formed when another rock's melted and allowed to cool and become solid? Igneous. You sort of ignite it. You melt it. What type of rock is formed when another rock is compressed or heated but not quite to the melting point? Metamorphic. So metamorphic is almost igneous, but not quite, or just sort of twisted around. This is where it gets a little tricky. Which of the following is closest to being turned into a sedimentary rock? Magma in a volcano? That's ready to become igneous. All it needs to do is cool. Rocks buried deep inside the earth? I don't think so. They're protected. Sand on the ocean floor? Yes. It just needs to be compressed, and then it's sedimentary rock. Sand is sediment. If you were given a rock and asked to turn it to igneous, which of the following methods could work? Break it apart and squeeze it? Nope. That's going to be sedimentary. Melt it and let it cool? Yes. And then this last one, heat it up enough to change its form, but don't actually melt it. That would be metamorphic. This rock has been squished and twisted, and that's makes it a metamorphic rock. An ocean hotspot. At an ocean hotspot, shield volcanoes are created. What type of rock are shield volcanoes made of? So they're made of lava that comes to the surface and hardens. That would be an igneous rock. Sometimes composite volcanoes can erupt violently. Bits of rock and ash fall from the sky and settle on the earth. That sounds a lot like sediment. Over time, these bits of rock and ash are compressed into rock, so that's sedimentary. And finally, the Himalayas happen when 2 continents smash into one another. And if you smash and smush and twist some rock, you get metamorphic. Let's see if I get 100. If I didn't, I screwed up the answer key. Yay, I got 100. All right, so people at home, just do that other quiz and you're done, and I'll see you tomorrow.